All right, so somehow we've got a pulley that is a thin ring, right? We got the string wrapped around the pulley, the standard thing, right? This is going to fall a distance of 1 meter, or not, possibly, right? Okay, and we want to figure out the acceleration of this system, right? How you make a pulley that's actually a thin ring. When you have to connect it to, maybe that's vanishingly light, a massless material connects us to this, right? Let's just go with it, right? There are pulleys that are essentially very close to, like a bicycle wheel is very close to being a thin ring. The spokes don't really count for a lot. Okay, so what I'm going to do is I'm going to set up a torque equation, right? So R times T, whatever the tension is in that cable. Now, it's definitely not the weight of this mass, okay, because this thing will be accelerating down, right? So it's definitely less than the weight of that mass. Okay, but R times T, that's our torque. I'm using the formula torque is RF. So R times T is equal to I alpha, right? Which is equal to, well, if it's a thin ring, right, it's M1 R squared, right? And then alpha is just A over R. Okay. So if you're paying attention, the R cancels that guy, right? And then we have RT is equal to M1RA. And then we can cancel yet another R, right? And so T literally equals M1A. And that's because, of course, all this mass is out at the tangent. It's right where the force is being applied. And so, yeah, that's why it's accelerating. So it's a bit like that mass on the plane. We've done problems like that, right? Where there's an object sliding along a plane and there's no other force, right? And now let's look at this mass here, right? We've got, for this guy, our formula looks like this. It looks like M2 minus M2G is the force down, right? The force of gravity minus the tension is M2A. And now we're set. Now we can just plug this in, right? So I can plug in M1A for T, right? So M2G minus M1A equals M2A. And then I can say M2G is equal to M1A plus M2A. And then if I factor out the A's, I get A outside of M1 plus M2. And I get finally that the acceleration is equal to M2G, which is the only force causing the acceleration over M1 plus M2. Now, when we did this with a cylinder, the mass of the cylinder had a coefficient of 1/2 in front of it. But since the M1 is all concentrated at the edge, it basically all the mass has the same linear acceleration as this mass. And that's why it's a 1 there, because all the mass is out at the edge. Okay, that's kind of how those work. All I have to do now is just plug in numbers for this, right? So let's see, M2 is 0.162. And then M1 is 4.52 plus 0.162. 0.162 times 9.81 divided by parentheses 4.52 plus end parentheses. And I get that the acceleration is 0.339 meters per second squared. If I wanted to find the velocity after a meter, I could use v squared is u squared plus 2as. Right? Make that 1 meter. Make that the acceleration that I just found, right? And I can solve that. So square root of 2 times the answer I just got times 1. And I get that the velocity is 0.824 meters per second, roughly. So we've got the acceleration, we've got the velocity, okay? I'm going to show you how to do this with conservation of energy, okay? So that'll be the next video.